so we're going to be talking about radicals and rational exponents. All right, you can write something in radical form. That means it's going to have a root, like a square root or a cube root, okay? And then you can write things in exponential form, where they have a power, right, an exponent. All right, they're interchangeable, so you can write one in one form and write it in another form. So fractional exponents are actually roots. They are radicals, all right? So if I look at this right here, my root number is called my index, okay? And then underneath here, I've got my a to the fourth. I want to write this in exponential form, meaning I don't want the root here anymore. I want an exponent instead. So what you're going to do is you're going to keep that number that's the base. And then up top, you're going to have a fraction in your exponent. And that fraction is going to be whatever your exponent is divided by your root number or your index. And you're done. All right? And you could go backwards. 3 is your root, right? And the way I remember this is roots are in the bottom of trees. Okay? So your root number is always in the bottom. All right? And so that would be your root number, and then that would be your exponent to this underneath. Okay? So I'm going to write this one in exponential form. Notice, and we talked about this the other day, that 7 could be underneath, right? Or it could be on the outside. It doesn't matter. So I've got my 5. I'm going to keep the base. And remember, the root number, which in this case is an 8, that's going to go on the bottom. And then your exponent is going to go in the top of the exponent. So I wrote both of those in exponential form. And now I can go backwards. All right, so 3, that's going to be my root number. So when you make your root here, by the way, they have like a fancy little shelf for your root number to go on. I always just do this little thing like a square root, but inside that you're going to put a little 3. You want to make sure that that's inside your little crook so that I know that that's a root number and not just a 3 on the outside. And then you've got your b, and you're going to raise that to the 4th power. Okay, so same thing here. The root number is the 7. Roots are in the bottom. And put that in the little crook. All right, you've got your base, which is the negative 15. And we're going to make sure that we keep that in parentheses because it's negative. And then we'll raise that to the 5th power. So something I just want to point out here is when you've got like a to the 1/2 to the 2, the 1/2 and the 2 are inverses, right? And you end up multiplying those, and they just make 1, right? Anything times its inverse is 1. So like 1/3 times 3, 1/4 times 4, 1/5 times 5, and they just end up being the base of your exponent there. All right, so we're going to let n be an integer that's bigger than 1. All right, and n is representing our root number, our index. And we're going to let a be a real number. So if your root number is odd, so 3, 5, 7, 9, then you only have one real root. All right? If your root number is even, so 2, 4, 6, 8, 10, and the number underneath is bigger than 0, so 1, 2, 3, 4, 5, 6, 7, then you have 2 real roots. So in other words, let's say that I had the 4th root of 2. My answer is always plus and minus. Okay? I have 2 answers, and this is why. If I asked you, like we're familiar with square roots, right? By the way, it's a square root if you don't have a number out here, that's a square root, because we understand that we don't need a number there for that. So if I ask you what the square root of 4 is, that means what number times itself equals 4? Well, 2 times 2, that equals 4, correct? But negative 2 times negative 2 also equals 4. So I actually have 2 answers. a positive 2 and a negative 2. That's why we have the plus and the minus. Okay? If your root number is even and the number underneath is 0, then you just have one root. That's 0, right? Because you can't have a positive 0 and a negative 0. 0 is just 0. And then if the number underneath is negative, you don't have any real roots. So let's say I take the square root of negative 4. There's nothing times itself that equals a negative, because two positives multiplied together make a positive, and two negatives multiplied together to make a positive. So I don't have any real roots. Okay? So we're going to find the indicated real nth root of A. All right, so n represents your root number. So this is a cube root. And then underneath, negative 27. So when I take the cube root of something, I'm looking for a number times itself 3 times that will make negative 27. Now, when n's odd, you can have a negative number under there, but you're only going to have one answer. All right? So what number times itself 3 times will give you negative 27? Not negative 9, because negative 9 times negative 9 is already 81. So it would be negative 3, right? Because negative 3 times negative 3 times negative 3, that equals negative 27, right? So the cubed root of negative 27 would be negative 3. So that's the number times itself 3 times that will equal negative 27. So when your root's odd, you're only going to have one answer, right? Only one answer. This time your root is 4, so I have the fourth root of 16. This means what number times itself 4 times equals 16? Well, 2 times 2 times 2 times 2. That equals 16, right? And also, negative 2 times negative 2 times negative 2 times negative 2 equals 16. So your answers are a positive and a negative 2. Notice right here, even root, correct? And the number's bigger than 0, so you have a positive and a negative answer. So anytime you have an even root, you better make sure that you have a plus and a minus. All right, so number 3, we have a cubed root. So when your root number, your index is odd, you're only going to have one answer, right? What number times itself 3 times will give you negative 125? Negative 5. Only one answer, right? By the way, if you take an odd root of a negative number, you're going to have a negative answer. Okay, if you take an odd root of a positive, it'll be a positive answer. All right, so 6th root, that's an even root. So how many answers are we going to have? 2. And so we're looking for a number times itself 6 times that equals 64. All right, a positive and a negative 2. A good way for you to check those is you can always say, okay, if I take 2 to the 6th power, that would be 2 times itself 6 times, right? And I get 64. Also, negative 2, but if you do that, you need to make sure that you put it in parentheses and check that. That's 64, right? So you can always just sit there and keep trying numbers until you get the number that you want. All right. Now, sometimes we just get to a point where we don't want to guess anymore. And we're going to talk about that in the next lesson, okay? So for this lesson, we're just going to kind of do, though, we've got to think about what the answer would be. So I have a cubed root again of a negative 8. So what number times itself 3 times gives me negative 8? Negative 2. And again, if you wanted to check that, all you have to do is take negative 2 in parentheses and raise that to the third power, because that's negative 2 times negative 2 times negative 2, and you get negative 8. Okay? So whatever your root number is, that would be your power when you're checking these, right? All right, this time the negative's on the outside, which is fine. Leave it there. And then you're thinking, what number times itself 3 times gives me 8? 2, but then I have to take it times that negative, so it's really negative 2. Now remember, the 2 is this part. The negative gets tacked on at the end. All right, now, it's easier to think about things when you see the root. So let's write this in radical form. So we have a fourth root of 16 to the first power, right? So do I need to put the 1 right there? No. But I have an even root, which means I'm going to have 2 answers, a positive and a negative. And what number times itself 4 times equals 16? Positive and negative 2. Okay? Number 8, you have an even root of 4. And this is negative 16 to the first, so that's just negative 16. So when you have an even root, what should you not have under here? A negative, because that gives you no real roots. You don't have any, so no real roots. In Algebra 2, you actually talk about imaginary numbers when you square root, fourth root, whatever negative numbers you get in imaginary. So we don't have any real roots. So when you have an even number here for your index, your root number, make sure that you check this number here. If it's negative, you don't have any real roots. Okay? You can have a negative if this is an odd number, just not when it's even. Okay? So this is already in radical form. What number? This is odd, so it's okay for us to have this negative. What number times itself 3 times equals negative 125? Negative 5. All right, on number 10, we're going to go ahead and make this in radical form. So when it's a square root, when that's a 2, you don't have to put the 2 out here because it's just understood to be there. It's like not putting a 1 in front of an A. All right, so I have 25 to the first power. So this is an even root, which means you're going to have 2 answers, a positive and a negative. What number times itself makes 25? 5. So 5 and negative 5. Number 11, write that as a root. So I have the fourth root of 16 to the third power. Now, I actually need to figure out what that number is underneath here. So we've got the fourth root of 16 to the third is going to give me 216. So I'm looking for a number times itself 4 times that gives me 216. Not 216. 4,096. That's what happens when you type the wrong number in. All right, so my advice would be to just keep taking numbers and raising them to the fourth, right? So if I do 2 to the fourth power, that's 16, okay? 3 to the fourth power, 4 to the fourth power. If you keep going up, finally 8 to the fourth power gives you 4,096. And since it's an even number, that's going to mean positive and negative 8. So 8 times 8 times 8 times 8 gives you the 4,096 as well as the negative 8. All right, so now on number 12, we have an odd root, which means we're only going to have one answer. So the cubed root of, keep your base and raise that to the fourth power. So let's figure out what 27 to the fourth is first. 27 to the fourth power is a really big number. 531,441. So we need to find a number times itself 3 times that will make 531,441. All right, and it's 81. So 81 to the third power gives us the 531,441. And it's just one answer, right, because this is an odd root. All right, so with the rational exponents, we already know that we can take them and write them separately, correct? And sometimes it's easier to put the exponent number on the outside instead of the inside. So what I mean is, here we have a root of 3. So we have a cubed root of negative 64. And if you know anything about 64, you know that 64 is a perfect cube, right? 64 can be found by taking 4 to the third power, right? But we still have this exponent of 2. But if I put the 2 under here, then I'm going to get that really big number, right? So this one, it's actually easier to take it and put it on the outside as the exponent. Then, since I know that's a perfect cube already, I can take the cube root of it. So what number times itself 3 times gives you negative 64? Would be negative 4, right? So inside here, that's negative 4, but I still have to take it to the second power, and negative 4 squared is 16. That was easier than the gigantic numbers, right? So sometimes it's easier to put the number on the outside, and you kind of just have to assess that situation, okay, and decide, okay, is that number a perfect root? If so, I'm going to do that first and then do the exponent. But if it's not, then you should do the exponent and then take the root. Okay, you can do either one. It doesn't matter. All right, so we have a square root. So in this answer, we're going to have how many answers? 2. So we have the square root of 9. What do you know about 9? Is that a perfect square? Okay, it is. So let's go ahead and put the 5 on the outside. So we have, what multiplies by itself 2 times to give you 9? 3 and negative 3, right? So 3 is one answer I get. I have to raise that to the 5th power. And negative 3 is also an answer I get. I have to raise that to the 5th power. So if I take 3 to the 5th power, I get 243. And if you take negative 3 to the 5th power, you get negative 243. So we have a positive and a negative 243. So you need to assess in the beginning if this is an even root, you're going to have 2 answers, right? All right. So now we have a 4th root of 256 to the 3rd power. So let's decide first, is 256 a perfect 4th power? Yes. All right. You get a positive 4 and a negative 4. So I know I have 2 answers, correct? I have a positive 4. I'm going to raise that to the 3rd power. And I also get a negative 4 raised to the 3rd power. So when I take 4 to the 3rd power, I get 64. And when I take negative 4 to the 3rd power, I get negative 64. So I have a positive and a negative 64. All right, and then on number 16, you have a square root of 16. Now, we already know that 16 is a perfect square, right? So I want to do that part first and then raise it to the 3rd power. So what number times itself gives you 16? 4, a positive 4, and also a negative 4. So I need to raise both of those to the 3rd power. 4 to the 3rd power gives me 64. And negative 4 to the 3rd power gives me negative 64. So I get both of those.